that complete topic is. Okay, so we discussed that we have different groups and different periods in periodic table. All right. So group numbers, what do group numbers tell you? What is the information that we get from group number? Who can tell that?
Uh, what's on the
Number
outer
of
shell, the last
Number
one?
of
valence
electron,
electrons.
Right,
electrons in last shell.
right, that's right. So group number, it tells us
Sir,
about. Yes, Amit.
could you ask someone in Pacific? Because we're all jumping over each other when we talk.
It's all right. I can still hear the response of everybody. Don't worry about that. All right. So it's perfectly fine. That is actually the reason that I ask a general question so that I can hear the views of everyone. So it's all right. Okay. So it tells you
Okay.
the number of valence electrons. All right. So number of valence electrons is actually a very important information. Why? Because these determine the chemical properties. Number of valence electrons will tell us about chemical properties of any element, right? Because for example, if something has, let's say sodium has one valence electron, it is in group 1. All right, so what does it mean? How will it complete its valence shell?
By giving away one electron.
Exactly. Now sodium will become sodium positive ion and it will give off one electron, right? Similarly,
So, and this thing that receives there will become minus.
yeah, exactly. Of course, it will not just donate its electron into the air. It needs an acceptor as well, or it needs something which will accept its valence electron. For example, chlorine. Chlorine has an electronic configuration of 2, 8, and 7. All right, it is 17. So chlorine will gain this one electron from sodium and become chlorine negative.
And become stable.
Right. So now this is the electronic configuration, not electronic configuration. Actually, this is one valence electron. So this is the same. The trend is same for all group 1 elements. Right? They all do the same. Right? So they all give away one electron and become one negative ion. All right. And similarly, all group 7 elements follow the same trend. They accept one electron and become a negative ion. How many of you remember what is the name of a positive ion and a negative ion? What is a positive ion called?
Cation and anion.
Good. Positive ions are cations. How do you guys remember that?
Sir, because
Cats and
cats are
anion.
good.
Oh, all right, cats and anions. All right, cations and anions. Good. Okay. So now I think you understand that in a group, chemical properties or chemical behaviors remain the same. All right. For example, if something is in group 1, it will always donate one electron and become a cation with a one positive charge. If something is in group 7, it will always accept one electron and become an anion with a one negative charge. Similarly, magnesium is in group 2, so you know that. What will magnesium do? Who can tell me? How will magnesium fill its valence shell? Go
In
ahead.
which
By
group?
of 4 electrons.
2A2.
Yeah, magnesium is 2A2. That's the electronic
Give
configuration.
away, it will give away two electrons.
It will give away, it will donate 2 electrons. And what will be the charge on magnesium then?
Sir,
Uh,
positive 2.
Positive 2. Positive 2 because it is donating 2 electrons. All right, so that is basically the whole reason why these all the elements are classified or are arranged in forms of groups. All right, all elements with the similar properties are basically in one group. It automatically is the same because they are arranged, of course, in increasing order of their proton number. But if you notice, then all the elements in a group will have same chemical properties. All right. So please write that down as well. All elements in a group, all elements in groups in a group will have similar. It's similar, right? It is, I'm using the word similar, not same. And why is that so? I'll tell you in a minute. All right, I'm using the word similar because they are matching. They're not exactly the same, but they all match. All elements in group will have similar chemical properties. Do you guys understand this? The word similar is used over here. I've not used the word same or exactly the same because the properties are just matching. The properties are not exactly the same. All right. So based on these chemical properties, we basically give names to certain groups. All right. Groups are given certain names. For example, group 1 has a particular name for it. What is it? Who knows? What is the name of group 1 elements?
Metals.
Yeah, they're metals. They're metals, but of course,
The metallic.
there's a particular name for it, and we call it the alkali metals. And why are they called
Yeah, and
alkali? They're called alkali metals because when we dissolve them in water, or when we when their oxides are dissolved in water, they form alkaline solutions. The solutions with pH greater than 7. All right. For example, sodium. If sodium oxide is dissolved in water, all right, if it is dissolved in
Sir,
water.
and the last group, zero, they're called noble gases, yes?
Yes, yes. The last group, the group 8, is called noble gases. We'll discuss them all right now. All right. So when sodium oxide is
I know
dissolved
them.
in water, it gives off these OH ions, which are basically responsible for alkalinity. All right. This forms an alkaline solution. So that is why they're called alkali metals. All right. All group 1 elements are called alkali metals. So next time when we talk about alkali metals, you must immediately understand that we're talking about group 1 elements. All right. Similarly,
Okay, sir.
group 2.
Sir,
Yes, go ahead.
group 1 metals, you have to keep them in oil, yes? Because they're highly reactive.
Yeah, sometimes, yes. Because they react with air as well. All right, not all of them. We'll study the trend in their reactivity as well. They are reactive, right? So that is exactly the difference that we wanted to talk about. They are reactive, all right, but not all of them are like super reactive. The reactivity changes, but the general trend is they are all reactive. Their reactivity is not the same. That is why we use the word similar properties.
Usually the lower ones are
Yeah.
Usually the lower ones are more reactive because they're farther from the nucleus.
Yes, that is fine. That is true. All right. So, but the reactivity changes. There is a trend in reactivity, but generally they're all reactive. That is why we've used the word similar for them and not the same, because their reactivity is not exactly the same. All right. So, and the group 2 elements are called alkaline earths, alkaline earth metals. My bad. Yeah, alkaline earth metals. All right. And the periodic table, you have seen it like something like this. All right. It is of this. It follows this curve. There are 2, 3, 4, 5, 6, 7, and 8. All right. And then there is this block in the center, and then we have 1, 2, 3, 4, 5, 6, 7, and then we have 8. All right. So this thing in the center, this block in the center, it is another group. It is called transition elements. All right. This block in the center is called TRANSI, transition elements. Why are they called transition elements? We will study about them as well. All right. Basically, right now I'm just telling you the different names of different groups. All right, and then we'll discuss their properties one by one. And then groups 3, 4, 5 do not have a very specific name. There are some distinctions there. There are some qualities, some similar properties in them. We will talk about them as well. All right. And let's talk about group 7 first. 5, 6, and 7. Group 7 elements are called
Halogens?
perfect. Group 7 elements are called halogens. Do you know why they're called halogens? What is the meaning of halogens?
No, I studied them.
They
Okay.
have both properties of metallic and non-metallic.
Don't
That
know why they're called.
they are metallic and non-metallic properties. They're called metalloids. All right, we'll study them as well. So that is actually when I said that these group 3, 4, 5, or 6 are not given a proper name because metalloids are somewhere found over here diagonally. All right, then they're not in the same group. I'll come to that in a minute. All right. Okay, so yeah, halogens are they're called halogens because halo is coming from color. All right, they are usually colored compounds. For example, some of them are gases, some of them are solids, so they have some very characteristic color. For example, some iodine has a purple or grayish color, or iodine vapors are purple. When it is in the solid form, it is grayish. And then we have bromine, which is brownish, and then we have chlorine, which is yellowish. All right, or yeah, and yeah, light yellow, pale yellow, that's clear. So these halogen, they're called halogens because of the color that they have. And then finally we have group 8, which are called, you all must know it,
Natural
Noble
gas.
Noble gases.
Noble gases.
noble gases.
Noble
Very good,
gases.
Ibrahim. Yeah, they're called noble gases. It's sometimes also called group 0. Why is it called group 0? Any idea?
Because they have no valence electrons.
How can they have no valence electrons? How's that? Think about it.
Oh, sorry, I
Because
mean
they're stable.
their valence shell is
They're
full.
very,
Yes, awesome. They're stable. Ahmed, you're also
very
right.
high.
Right, Hafsa, you're also right that the valence shell is full. For example, helium, it has only first shell, and the maximum capacity of first shell is, who remembers that?
8.
2. Good. All right. So helium has 2 electrons in its valence shell, and similarly, after helium, we have neon, and neon has also full valence shell. It also has 8 electrons in its valence shell. All right. Is it making sense so far?
Okay.
Yes.
Yes.
All right, let's move on. Okay, so that was a general overview of all the different groups. Let's talk about each group one by one now. All right, we'll start off by group 1.
Sir, we will have computer class today or not?
Let's see what happens after this chemistry class, and then we have
Okay.
time. The time will remain the same. I will see how it works. All right. Okay. So let's talk about. All right, let's start with the easy one. Let's start with group 8. All right, so that's very easy, very basic, or group 0 as well. All right, so group 8, the elements that are there in group 8 are called the noble gases, or we have already discussed that. All right, noble gases. And why are they called noble gases? Because elements,
Please use that.
yeah, please write it down.
Elements are
Elements
full.
in group 8, okay, do not write it like that, please. Elements in group 8 have a full valence shell. All right, they're called group 0 because they need 0 electrons to complete their valence shell, or they need to donate 0 electrons just to complete their valence shell. All right, and they're all gases.
Sir,
Yes, Amit.
do you know in the periodic table there's like a stair which separates the metallic and non-metallic?
Yeah, that's called the staircase line.
Oh, okay.
All right, we'll come to that as well. All right, so basically when Ellie was talking about metalloids, so those metalloids, they exist with that staircase line. Elements to the right and left of that staircase line are metalloids. They're just the gray area between the metals and the non-metals. So they have a mix of properties, right? They have both metallic properties and non-metallic properties as well. All right.
And sir, do you know to ion to happen for a plus and a minus change to happen, it has to be between a non-metal and a metallic
Yes.
element, yes?
Metals donate electrons to non-metals, right? That was
Okay.
in the ionic bonding that we were studying. All right. Okay. So another property about these noble gases is that they are inert gases. What is the meaning of inert?
I don't know.
Inert also means unreactive, all right? And now you know why they're called unreactive. You already know that. All right. So we just say that these gases are inert. Noble gases are inert gases. All right. And please
Okay.
list down the elements as well. That's helium. Where is helium used? Where do we use helium?
In balloons.
In balloons, right?
And sir, if you breathe it in, it changes your voice.
Yeah, that's because it has very less density. Right? It's one of the lightest gases. Other than it is of course more dense than hydrogen. So yeah, helium it is used in helium balloons as well, and it has, and then we have neon, and we need to know about the uses of all these. I'll just tell them in a minute. Let's just list down all the noble gases. All right, and after neon we have argon, and the symbol of argon. All right, and then we have krypton, then we have xenon, and then we have radon. All right, so krypton, xenon, and radon. Let's just write down the uses now. All right, okay, wait a second. Of course, I'll actually, please list this, note this down. I'll have to move on to the next page, write down the users. We do not have enough space left. So let me know when you guys are done.
Done.
Okay, all of you?
No.
No.
Take a minute, quickly note these down, and then we'll move on. My bad, radon is Rn. I don't know why I wrote RD. Okay, Is everybody done? Shall we move on?
Yes, sir.
Yes.
Okay, we have already written the use of helium, all right, because it is lighter than air. It is used to fill balloons and also the airships that we have. All right, lighter than air.
Writing in class the learn.
Air is lighter than air, so it is used to fill balloons. All right, and actually a very fascinating part. Basically, hydrogen is also lighter than air. Hydrogen is even lighter than helium. Then why do we use helium balloons instead of hydrogen balloons? If you want something which is less dense,
I agree with this.
then
No, again, just
go ahead. Yes, Hafsa, you wanted to say something?
Because it isn't
There'll
reactive.
be two lights.
That is a good point. If they are too light, it is a good
This
point. The problem is, or basically the advantage is, that helium
hydrogen.
won't catch fire. Right? Hydrogen catches fire. Hydrogen is highly combustible. All right. Hydrogen is used as a fuel as well. We burn hydrogen to get a lot of energy. All right. So hydrogen is a
So
very
it's safer.
yeah. So helium is safer. All right. Yeah. It does not catch fire. That is why we prefer this over hydrogen. Although it is more dense than hydrogen. If we use helium, it will. If we use hydrogen, it will be much lighter. It might be more efficient, but it is not safe. It does not catch fire. All right. So the next noble gas is argon, and the use of argon is it is filled in light
Vacuum
bulbs,
tubes.
vacuum tube light bulbs, right? So how many of you have tried to bang a light bulb against a wall?
Sir, wasn't neon second?
Neon is
this one I'm mainly used right.
used in those
I did it. I
advertising.
got in trouble.
Okay, that's nice. Hafsa, neon is used in those advertising lights. It's that shiny. We use neon lights, especially in the dark, on some neon shirts as well. People who just want to live with the swag. All right, so yeah, that is where neon is mostly used. All right, yeah,
Sir, and neon glows.
yeah, it glows. All right, it is used in light bulbs, and it is also used in welding, right? So it is used in welding of metals as well, because this is an inert gas. At when we are welding something, when we are welding metals, a very high temperature is reached. All right, and oxygen or any other gas, let's say um, hydrogen, it will burn at high temperature. But because
So you
argon,
skip neon.
okay, fine, yeah, we'll do that. Actually, okay, fine. Argon. Okay, let's do this, and then I'll go to neon as well. Welding of metals. Why? Because it is unreactive. Neon. Thank you for telling, Shazib. It is used in advertising lights. We all have seen neon boards. All right, and it glows. Why? Because it glows red basically, but its color is changed. We see neon lights of different colors when it is mixed with other gases. All right, it glows red, but color can be changed when mixed with other gases. But color changes. Originally, it only glows red. Oh my god. But color changes when mixed with other gases. All right. So yeah, and the next is Krypton. It's mostly used in car headlights. All right. And some lasers as well. And finally, we have xenon. Radon is basically radioactive. We do not necessarily use in daily applications because radioactive substances, one, they are harmful, right, for the daily use, plus radioactive substances decay. So they cannot have a permanent use. It has different applications
So
in
you vote
radioactivity.
2, 3.
2, 3, 4, and that's 5. Thank you, Amit. So yeah, xenon, it is used, it also used in headlights, and it is also used in lighthouses. How many of us have seen lighthouse on a beach, maybe?
Group work.
So not on the beach, but I've seen
I've
one.
seen pictures of it.
All right, fine. So it is used in operating rooms, right? You have seen that bed in which the patient is
Yeah,
lying,
but my son and your son and
right?
my son are
On mercy of doctors, and
my
he
son
has
is working on his English maths
a huge lamp
above
on
the
it,
page, but
okay,
his
a very
writing
bright lamp.
is not there. But I told him English
So that bulb has xenon in it. All right. Okay, and its light is basically similar to the daylight, very bright, and the color of the light coming from xenon is also like that.
and then you can start modeling it, and then you can copy something, Laura, and you could just select the verbs and say, let's change the verbs, see what happens. Yeah. Let's
Emmett,
change
do
this
you
verb now.
have to go, or will you stay?
Scaffold it. Scaffold it.
I think I might stay if the connection's still good.
All right, good. Okay, so yeah, that's it. Let me know when you guys have written this, and then we'll move on. Xenon is also used in that used with photographers, right? You might have seen in movies or in real life as well that initial photographers, they used to have a very bright bulb, right? And so they also use this xenon in it because it produces a glow, a light, which is just like the sunlight. All right. I'll move on.
Yes.
Okay.
So I'm still writing about xenon.
All right. Meanwhile, I'll just share this Jamboard with you all so that you can access this later on. All right. I will add your emails. Who's left? Ali Mansoor is also done. Yeah, I think everybody's here now. Okay. You guys will receive an email notification of this, and yeah. Okay.
Done, sir.
All right. Is everybody done? Ali Mansoor, are you done?
Yes, sir.
Okay. Give me a second. Come on. Okay. So now it's actually a basic thing that we need to study it as the size of, or the trend or the size of these gases, or as we move across down the group.
So are there only 5 noble gases?
Emma, I told you there is another one which is radon, that is radioactive. All right. If you look at this over here, we have radon as well. And now this is a radioactive gas. Now radioactivity is a whole new thing which we will study in physics as well in the last topics. All right. So for now, you just need to know that these are unstable compounds and these are harmful compounds. All right, harmful gases or harmful elements.
But sir, it's in the noble group. How's it unstable?
That doesn't mean that it is unstable chemically. It is unstable physically. All right, it changes itself into some other forms of other element. It is just releasing certain waves, certain radiations. It won't chemically react. It is still stable in that matter. All right, but it emits some of the harmful radiations. That is why we say it as unstable. It decays. It won't react chemically. There are some physical changes which are happening in this.
Okay.
All right. Okay. So yeah, let's talk about the size of this noble gases. And basically, this is true for all the groups and for all the elements. All right. What happens to the size of element as we move down the group? Who can tell that? Will it increase or decrease?
Decrease.
Yeah. It increases. Why? Because, okay, what happens to the number of shells? Are they increasing or decreasing when we're moving down the group? Basically, from one period to the next.
It decreases.
Okay.
They're increasing.
Increasing.
In first period, how many shells will we have?
2.
1.
2.
One shell in the first period. All right.
Yes.
All right. And the second
How,
period.
sir?
Shazib,
He said period, not group.
what is period number?
Oh.
Shazib? Okay, good. Period
Yes,
numbers gives us information about number of shells, right? In the second group, we have 2 shells. All right. Similarly,
Yes.
in the third period, we will have 3 shells. So you can imagine
3 shells.
what should happen to the size of atom as well. Helium, it has only 1 shell, and neon, it has 2 shells. So what should happen to the size of atom as we're moving down the group?
it increases.
This is group 0. Of course, it
Decrease.
increases. Hafsa, is it increasing or decreasing?
Increasing.
Increasing, right? So argon is having now 3 shells. All right, which means the atoms are getting bigger as we're moving down the group. All right, so atoms keep on getting bigger as we're moving down the group. So that is why the van der Waals forces that are in between these atoms, they increases. All right, down the group size increases as we move down the group. Please write this down. Down the group. As we move down the group, what happens? Size of atom increases. All right. And when size of atom increases, the intermolecular forces increases. All right. Intermolecular forces also increase because they depend upon the size.
There's lots of
What is that?
Intermolecular forces are basically the forces between one atom and the other atom. I'll explain it in a minute. All right. Intermolecular forces increase. All right. Yeah. And when intermolecular forces increase, of course, the boiling point or the melting point also increase because of course they're already gases. We cannot melt or boil them, but when you liquefy them or especially for fractional distillation, which was also the question in your test, because to obtain these gases from fractional distillation, we usually liquefy them first. All right. And then we start increasing their temperature. And then the whole process of fractional distillation, the way it works in liquids, it is exactly the same. All right, melting
So
point and
as
boiling
the
points.
forces increases, the boiling point and melting point both increase.
Of course, both will increase, but they increase one by one. For example, there has to be a difference in melting point and boiling points, and which is actually we do not usually reach the melting points in case of gases, because we cannot make gas a solid. All right, some gases can be converted into solid. For example, you guys should know about one. Which gas do we have in the solid form? Can you guys recall? For example, the gas which is normally at room temperature, but we can
Iodine.
Dry ice.
Dry ice. Iodine is a solid at room temperature, right? Carbon dioxide can be liquefied and converted into, converted into solid.